Please wait for 2-3 minutes. Let's join others. Then we will start the session.
Okay, ma'am. Okay.
Okay, let's start the session. This is week 8 microelectronics device to circuit session. I'm Arpita Biswas, a PhD student from electrical engineering department from IT Jodhpur. So this is more details about me. So let's start the session. This is the question number 1. As the output resistance of the constant current source of a MOSFET based differential amplifier increases, the CMRR. First option is the decreases, second option is increases, third is remain the same, and option B is become 0. So please take your time, go through the question carefully and try to find out the right option.
Ma'am,
Yes,
ma'am, option B, ma'am, I think.
yes, option B is the right option. So this is the question number 2. The voltage gain of the differential amplifier shown in the figure below can be approximated as. So please try to find out the right answer. There is no hurry, you take your time.
Ma'am, I think D.
No.
D,
Carefully
ma'am.
try.
D.
No, option D is not the right option. Take your time and again try to solve. Hurry, how to solve this question? Jen,
Ma'am, can you please explain?
okay. Surya Satvik, can you please explain how you have solved? Then I will explain. Jen, you have to find out the voltage gain, right?
Yes, ma'am. Voltage gain we have to find it, ma'am.
Yes. AV you have to find out. Now tell me, what is the formula how to calculate this AV? Tell me.
Ma'am, R total is equal to R2 parallel to GM4 R resistance 04 plus R06, ma'am.
See, AV equal to GM1 into R output. Okay. Now you have to
Yes, ma'am.
find out the R output. See, every time I am giving the right answer, it is not also okay. Okay. If you have any doubt, you can cross check it. Okay. So R output you have to find out. R output is R0, R02 parallel with, just ignore my handwriting, R02 parallel with GM6 into R0 R06 into R04. Okay. So the final AV equal to GM1 into R02. See, if you're seeing from here, this one and this one is parallel, right? So R02, it is parallel with that one. So it is GM6 into R06 into R04. Sorry, not this one. This one. R02, which is parallel with GM6 into R04. So option C is the right option. Okay, next move toward the question number 3. Identify the transistor forming a current mirror circuit in the given op-amp topology. So which one is the right answer? M9, M10 or M7, 8, 9 or M1 and M2 or M3 and M4? If you go through the lecture video, you have seen like the current mirror and identify the transistor forming the current mirror circuit. So in the given op-amp topology, you have to find out the current mirror circuit. Tell me which one.
Give me a minute, ma'am.
Yes.
Option D, ma'am.
Option D, ma'am. Option D. M3 and
Option
M5.
B, right?
Option D, ma'am.
Yes, option B is the right answer. M7, 8, and 9. This one. Then it is 8, 7, and this 9. Okay?
M9.
Yes. So this is the question number 4. Find out the value of a small signal input resistance for the amplifier shown below. Let the DC current through the M1, M2 be 500 microamps. W by L is 100 microamps by 1 microamp. Micrometer, sorry. W2 by L2 is 200 micrometer by 1 micrometer. Assume the parameters of the NMOS transistor are mu and COX is 110 microamps per volt square, and VTH is also given. And for the PMOS transistor, mu P COX is given 50 microampere per volt square, and VTH P is also given. So consider R1 equal to R2 equal to 10 kilo ohm, and RL is 1 kilo ohm, and VDD is 5. So ignore the RDS1 and RDS2. So find the value of the small signal input resistance. R input you have to find out.
I think answer is C, ma'am. 20 kilovolts.
No, not 20 kilo ohms. There is no hurry. You take your time and try to solve. Okay, I'm coming back in 1 minute. You try. Okay, tell me the right answer. Hello. So
Ma'am,
first, yes.
to this problem, it is coming long answer, ma'am.
See, first you have to find out the GM1 and GM2. Tell me how to find out the GM1. What is the formula? Twice of ID mu and COX
W
W
by
by N.
W by L.
Yes, for M1. Okay. Now tell me what is the value of this GM1. Calculate it. 2 into 500. Tell me the answer. What is the value of this GM1? 3 point, calculated 3.316 ms. Now the same way you have to find out the GM2. Just W by L for M2, okay? So what is the value? 3.162 ms. And what is this now? Just draw the small signal model. It is parallel to RL, right? Am I audible? Hello? Hello?
Yes, ma'am. Yes, ma'am.
Okay. And this value is GM1 into VGS. And this is R2. And this is R1. And across this, there is a VGS voltage. Okay. This is positive and this is negative. So tell me, what is the value of this VT? Can we write it? Like VT equal to R1 plus R2 into I2, IT plus RL into IT minus GM on VGS minus GM to VGS. Okay. So there is a write the next line and VT minus VGS by R1 equal to IT. Can we write it? The value of IT. So what is the value of this VGS here? VGS equal to VT minus ITRT. Okay. So I have to erase this. Just remember the value of this GM1 and GM2. So therefore, VT equal to R1 plus R2 into IT plus RL IT minus VT minus ITR1. Into GM. Sorry, into GM1. Here is a GM1. Just a minute. There is a it is here. So into GM1 minus is minus VT minus ITRT. ITR ITR1, sorry. ITR1 R1 into GM2 into GM2. Then the second bracket close. Now just take common of VT one side, VT into 1 plus GM1 into RL plus GM2 into RL. The R, this is L. Okay, this is the this side, and then equal to IT into this second bracket, okay? R1 plus R2 plus RL plus R1 into RL, just take common, into GM1 plus GM2. Okay. So here the value of R in equal to Vt by It, right? Vt by It. So from the equations, tell me what is the value. Just Vt. This side you have to write the under the Vt is It. So equal to R1 plus R2 plus RL plus R1 plus R1 into RL into GM1. This is GM1, right? Plus GM2 by 1 plus GM1 into RL into GM2 into RL. Just write down this and then I will remove this, erase this one. Please write it. Then I will erase and I will write the final answer, the value of this R1, R2 and RL. So can I erase this? Hello?
Yes, ma'am.
Yes, ma'am.
Okay. Then what is the value of this R in?
$11.47 kilo ohms.
No. Just see the calculation.
Okay, ma'am.
10 to the power 3 plus 10 into 10 to the power 3 plus now tell me what is the answer. Just calculate and find. Let's check. It is 11.47. Just check the calculation part. It is 11.47. So can I move towards the next question?
Yes, ma'am.
Okay. So this is question number 5. Find the CMRR of the differential amplifier shown below. If there is a mismatch of 10% between the resistance, consider the GM1 and GM2 is 5 milliamps per volt and RSS is 50 kilo ohm. Tell me how to find out.
Is the answer C, ma'am?
Yes, answer is C. Tell me how to find out.
Ma'am, ADM is equal to GMRT, ma'am, because we have to take the equation first.
So mismatch is
Mismatch
10%.
is
So
10%, ma'am. 1
CMRR
by
formula is,
ADM by ACM.
yes, C. Twice of GM into RSS by delta RD by RD, right? For the from this you can find out. So twice of GM is 6 into 10 to the power minus 3 into RSS is 50 kilo ohm, right? Yes, 50 kilo ohm. 10 to the power 3, right? What is the value of this delta RD? It is 0.1. What is the value of this RD? Sorry, yes, RD is 10% and by total RD. So this is 0.1. From here you have to find out like this this delta RD by RD is equal to 0.1. Like 10% mismatch, the RD is 10% by 100. Okay, so 0.1. So now tell me the final answer. CMRR is 600. Sorry, 6,000. So the answer is option C. So can I move towards the next question? Question number 6.
Yes, ma'am.
This is the question number 6. An op-amp has a differential gain of 110 dB and CMRR rating of 100 dB. So what should be the common mode gain of the amplifier?
On option B.
Yes, option B is the right option, the 10 dB, right? Because CMRR in dB equal to, tell me what is the equation? 20 log AD by ACM. AD is the differential gain. So you have to find out the AD, right?
Device.
Yes. So just here you have to find out the value of AD. Just both side, the CMRR in dB is equal to 20 log AD minus 20 log AC. CMRR in dB is equal to AD minus ACM. So AD AC dB and AD dB minus ACM. So AC equal to 110 minus 100. So it is 10 dB. Okay. So next question, a MOS differential pair has a tail current is 100. Sorry, 10 current I is 200 and overdrive voltage is 0.2 and differential input is 0. So find out the drain current through the each transistor. See, the differential input voltage is 0. Overdrive and tail current is given. Tail current means this side, like this is called tail current. And here is the M1 and here is the M2 and it is mostly identical because the differential input is 0. Now tell me, if the I equal to 200, then how much current is going through this M1 and this M2? Tell me. Total is 200. So equal amount of current is flowing through this M1 and M2. So one side it is I by 2, right? I by 2. So 100 microamps answer is 100 microamps. So this is question number 8. Input impedance of an ideal op-amp should be dash, whereas its output impedance should be dash. Tell me the right answer.
I or no. B.
Yes.
B. No. B option.
Yes, high and low. Good. Question number 9. Find the time constant of the circuit shown below. Consider RS equal to 1 kilo ohm, RP is 5 kilo ohm, and CS is 3 picofarad. Tell me the right answer. How to find out the time constant? RC, right? It means RS plus RP into CS. Now tell me what is the right answer. Thousand plus 5,000 into 3 into 10 to the power minus 12. So answer is 18 second, right? 18 nanosecond. So next question, find out the transfer function V output by V input of the circuit shown below. So try to find out it. What is the right answer here? This time I am not going to calculate it. You have to find out. Tell me the right answer. Hello. Hello. Am I audible?
Yes,
Yes,
ma'am.
ma'am.
Okay, so the right answer is option D. You have to find out this. I'm telling how to find out. Like V output is equal to V input into R2 plus 1 by SC2 by R1 plus 1 by SC1 R2 plus 1 by SC2. So you have to find out this way. Okay, just see this one. V output equal to V input into R2 plus 1 by SC2 by R1 plus 1 by SC1 plus R2 plus 1 by. So you have to just find out, calculate it in the right way. S into C2. Okay. The right answer is option D. So this is the question number 11. Differential gain is given, common mode gain is given. To find out the CMRR in dB. I'm not going to find out. Tell me how to find out it. It is the easy question.
CMRR equal to differential gain by common mode gain.
And in dV, how to find out? 20 log AD by SCM. Okay. Now tell me the answer. 20 log AD by SCM. CMRR in dV equal to 20 log base 10.
Ma'am, I got 72.04 dB. Ma'am.
Yes, 72 dB. Yes, right. AD by SCM. SCM. And the answer is 72 dB, almost 72 dB. Good. This is a question number 12. Why are PMOS devices often used as an active load in MOS differential amplifier? So try to find out the right option.
Ma'am, B, they provide large effective extents.
Yes, option B. This is the question number 13. What happens if gate and drain of MOSFET are connected together? So right option is option C. Device operates in triad region like a register. Next question number 14. For the differential pair with identical load, find the approximate differential gain. So AD, you have to find out. Tell me the equation, how to find this AD. Half of GM are not. Then tell me the right answer. What is the value of
Minus
this?
50,
Yes,
50, ma'am.
25, right?
Yes, ma'am. Of course.
Yes. Next question number 15. Differential amplifier given, common mode gain given, find the CMRR in dB. Same way you have to find out.
Eighty dB, ma'am.
Yes, 80 dB. Next, AD given, GM given, find the R naught. Similar equation, the AD equal to half of GM R naught. So then you have to find out the R naught. Tell me what is the value of this R naught. R naught equal to then twice of AD by GM. Tell me the value of R naught.
Ma'am, ma'am, 80 kilo ohms only, ma'am, with the answer.
R naught is 160 kilo ohms. Just cross check it. AD is given na 100. Then 100 twice of 100, it is 200. And then the below side, it is GM 1.25 into 10 to the power minus 3. 200 by 1.25 into 10 to the power minus 3. Tell me what is the answer?
80 member.
Okay, 80. Okay, then it is 80. 200 by, this is the calculation part. 200 by 1.25
to 10 to the minus 3.
into 10 to the power minus 3. Yes, this is the answer. It is 80, right? 80 kilo ohms. Next is the question number 17. In an ideal MOS differential pair with the identical transistor and resistive load, the output for a pure common mode input is maximum positive voltage, maximum negative voltage, zero differential voltage, or infinite gain.
C. Option C.
Yes, option C is the right option. A MOS differential amplifier GM is given, RD given, find the differential voltage gain.
Ma'am, 20 ma'am.
How to find out? Tell me.
Ma'am, AD is equal to minus GMRD ma'am, please.
Yes. So AD equal to GMRD, it is 20. Next question, differential amplifier ISS is equal to 400 microampere, W by L is given, Kn dash given. Find out the overdrive voltage. Just cross check it, okay? V overdrive voltage, are you getting 0.3?
0.316.
316, yes. Tell me, just explain it, how to find out.
ID is equal to IHS by 2 ma'am. First we have to
Yes.
take the then
Okay.
the
V equal to half of Kn dash W by L into V overdrive whole square, right? Then just
ma'am.
put all this value. So, the overdrive is 0.316. Then question number 20. A MOS differential pair has an overdrive voltage 0.2. Find out the maximum differential input voltage. How to find out it? Tell me. VID max equal to root over V overdrive. Tell me the value. 0.4
0.4.
or 0.283. Like root over 2 into V overdrive, na?
Okay.
Root over 2 into V overdrive. So this is the question number 21. The differential output voltage of a MOS transistor pair is given by. Tell me the right answer.
Your
Option B is the right answer.
option B ma'am.
Yes. This is the question number 22. The differential gain of a MOS differential amplifier with the resistive load is which one?
C, ma'am. GM.
Yes, C is the right answer. Question number 23. A mismatch in transconductance delta GM of input MOSFET leads to. Which one is the right answer?
C, lower CMR.
Yes, lower CMRR. Then a MOS differential amplifier has GM equal to 1.2 milliamps per volt, RD is 10 kilo ohm, R naught is 100 kilo ohm. Find out the AD. AD equal to?
AD equal to RD parallel to R0.
Yes, a GM into RD parallel to R naught. Now tell me the value.
Minus 10.908.
AD equal to, just cross check it, it is 10.9 or not.
I have small doubt now.
Yes.
Ma'am, the values coming in negatives, ma'am. Is it any problems with the answer?
Sorry.
Ma'am, the answer is coming in negatives, ma'am.
Just a GM into RD into R naught. So GM value is 1.2 into 10 to the power minus 3 into RD and R naught 10 kilo into 100 kilo by 10 kilo plus 100 kilo. So the answer is like 1.2. Here you can find out the 1.2 into 10 to the power minus 3 into just R naught into RD by R naught plus RD. 1 into 10 to the power 6 by 110 kilo. Kilo means 10 to the power 3, right? Now tell me the answer. Like 1.2 by 110, right? Is this the answer?
Yes, ma'am.
Yes. So I think this is not the right answer. From here you have to find out like 1.2 by 110, right? Is this the right answer?
Yes, ma'am.
Yes. So next question number 25. For the MOS differential pair with V overdrive is given. Find out the maximum differential input voltage without turning off on transistor. So VID max you have to find out. What is the formula? Root over 2 into V overdrive. Now tell me the right answer. You have to find out the VID max. Root over 2 into V overdrive. Tell me the answer. 0.354. Is it coming or not? You can cross check it. Just you have to multiply the V overdrive with the root over 2. This is question number 26. Effect of drain resistance mismatch. Find out the ACM. How to find out the ACM? Tell me. This is the formula. Delta RD by twice of RSS.
Ma'am, finally, the numbers.
Yes.
1 into 10 to the power minus 4.
1 into 10 to the power?
Minus 4.
Yes, minus 4 is the right answer. Good. This is the question number 27. Find out the CMRR. Same way you have to find out. ACM, at first AD is given, I think. AD is GMRD. You have to calculate it. And then ACM, you have to find out the RD by 2. Just see. AD is GMRD, right? So GM and RD is 20. And ACM you have to find out. Tell me the equation how to find out the ACM. ACM is RD by twice of RSS into delta GM
100 dB.
by GM. Yes, 100 dB is the right answer. Okay. So from here you will get 0.0002. Okay. So in dB, how to find out? 20 log 10 base AD by ACM. Sorry, not equal to. A log 10 base AD by ACM. AD is 20 by 0.0002. Right? So what is the value? 100 dB. The first stage of a CMOS operational amplifier is usually, which one is the right answer? Option B, right? A differential amplifier. This is the question number 29. The single-ended output of a differential amplifier compared to a differential output has, what is the right answer? Tell me.
Half.
Yes,
the gain.
half the gain. Good. This is the last question. Power supply rejection ratio of an op-amp indicates ability to reject the common mode signal, ability to reject the variations or noise in supply voltage, ability to reject the load variations, or ability to reject the input offset.
Ability to reject the variations.
Yes, variation or noise in supply. Okay, today we are ending the session here. Next we will meet next Tuesday 7 to 9 p.m. Thank you.
Thank you.
Yes.
Thank you.
Okay.